Let's say you throw an object. Let's say you are here. You throw this stone from here. This is your hands position. You throw an object up in the sky, and the object travels, let's say it moves 10 meters up, and then it starts to come back down, and it is somewhere here, halfway down. So it has moved 10 meters up, and it has moved 5 meters down. The distance traveled by this object is this total length, 10 meters, plus this total length, 5 meters. Distance is a scalar quantity. It's a scalar. It doesn't have direction. You do not say whether the object is moving up or is moving down, but the total length it has traveled so far. If the object now comes back down to this level, the distance it has traveled will be 10 plus 10, which is 20 meters. Displacement, on the other hand, is a vector quantity, and you will measure the displacement. You can measure the displacement from the original point and say when it is here, the displacement will be this vector from the original point to that point. You can also, so before we move ahead, maybe you choose up as positive, and so down will be negative. So displacement will be from here. We say displacement from some point. So the displacement from the 0 position will be the vector from the 0 position to where the object is, which is 5 plus 5 meters. But we can also measure the displacement from the maximum point. The displacement from the maximum point will be the vector from the maximum point to the point where it is, which is minus 5 meters. Position is also a vector quantity, and many times in physics and mathematics we will interchange the word position and displacement. They will be used interchangeably. You will sometimes hear displacement, sometimes hear position, but there is a difference between the two, in that position is always measured only from the original point. So the position of the object at this point will always be plus 5. And when will position be negative? When the object comes down and then moves below that point. The position will be the vector from the original point to where it is now. Let's say it is 5 meters down. The position now will be minus 5 meters. So position and displacement are both vectors, but distance is a scalar quantity. Okay, there was this question. We are told that the diagram is a sketch of the position time graph for a ride, position against time. We are asked to describe the motion, what happens at the points O, A, B, C, and D. At the point O, we see that the position is 0. So the object is at the starting point. If it's a stone that was thrown up in the sky, at O it is here, and then at A the object has moved let's say 10. Let's say this point is 10. So at A, the object has moved 10 meters up. So this is the point A. At B, the object is back to position is 0 at B. So the object has come back to the original point or original position. At C, the position is negative. It's on the negative axis. So let's say this is minus 10. So the object has moved down negative 10 meters down. And at D, it comes back to the original position. So if this is vertical motion, this is what it is. It moves up, comes back down, comes down, comes back up. If it's horizontal motion, it starts at the point O, moves to A, passes through O again, moves to C. So this will be positive direction. So it moves like that, comes back, moves back, comes back. So it is a to and fro movement, or we call this an oscillation. So this type of ride is an oscillation, or you can call it a to and a fro movement. Okay.